Okay, hey folks, Mark Locklear here, and this is a screencast on Chapter 1. So this really lays the groundwork for everything you're going to learn for the semester and just for databases and relational databases in general. So I would say soak as much of this in as possible, yeah, just try and try and take as much of Chapter 1 in as possible, because really this is the nuts and bolts for everything we'll do the rest of the semester, and again, relational databases in general. So I'm going to share this, and actually let's do that. Okay, all righty. So Chapter 1, an introduction to relational databases. So first off, this is sort of the model that we're looking at, and I mean, as much as I can, I'll try to apply this to sort of real world scenarios that we've probably all used, either whether it's websites or using our cell phone. But again, obviously the database server you see at the top is going to be the focus of what we're going to be doing. And so how does that sort of play into the rest of the internet and applications and tools in general? So generally we have this cloud here that represents the network. When we talk about that, you can just think of that as where application servers and other things live at. But basically everything's in the cloud these days. I mean, the good old days of having a physical server at a particular location. It's not to say that doesn't still happen. If you go out in the real world and do real work, you very well could end up, working and maintaining a server or be in that environment. But more and more, and it's only going to increase as we go forward, is that servers and technology and data lives in the cloud, and whether that's Amazon Web Services or Azure by Microsoft or DigitalOcean, I mean, there's tons of them out there, and there's going to be more to come. So whether it's your application server, your database server, or whatever, it lives in the cloud. And again, the model we're looking at here, the database servers at the top, and then you notice you've got clients off to the left and right. Those are, could be your tablet, it could be your phone, could be your desktop you're working on. All of those things are connected to the cloud, so they're able to access data that way. All righty, so 3 types of hardware components. Again, we talk about clients, server, and network. So that's what these were here. The clients are things. So when you think of clients, think of things like, again, your phone, your tablet, your desktop. You can also think of that as sort of the end user. So you're the consumer. So whether it's Google and Gmail, let's just take email for example. When we talk about the client, the client is when you log into, if you use Gmail as an example, when you log into Gmail and you're interacting with email there, you would consider that the client. The server, when we talk about the server, we're talking about the sort of back end functions that happen there. So it could be a database, it could be an application server, those sorts of things. And then of course the network we talked about, again, represented inside the cloud here. The network is the sort of the hardware that this stuff lives on. Now again, often we don't interact with that at all. I'm old enough. I got started in the late 90s and the early 2000s, and my first job was a server administrator, and I had physical hardware. I had physical servers that I maintained. But again, more and more, you see that less and less. Again, that's not to say you won't see it out in the real world, but there's a good chance, if you're certainly on the software side as an application developer or as a database administrator, something like that, there's a good chance you're never going to see a physical server. It's going to all be cloud-based technology that you'll be dealing with. They've got some terms here: LAN, WAN, cloud computing. In my opinion, those aren't worth spending any time on. You can do your own research on those things. I mean, really, if you go on to be a network administrator, So you're doing like Cisco kinds of things. You're dealing with routers, those kinds of things. Usually those are the folks that are dealing with LANs and WANs and those things. Generally, as a either database administrator or an application administrator, you're probably not going to be doing much of that kind of work. Okay. So again, we talked about that client server model. You can see on the left side the client, and usually there's some application software there. These days, more times than not, it's often it's web based, so you're using a web browser to access things. So again, think about, as an example, Gmail or eBay or Google. You generally access almost all those services through a web browser. Now, if you have a Gmail application on your phone, right, you have an installed version of an app, that's an installed application. But yeah, that's the sort of client side. They've got a note about data access or API there. Those applications use an API, what's called an API or application programming interface, and that will often interface with a back-end server. And in this case, the example they're using here is there's a database server that data is being retrieved from. So everything you do on a website or an application, there's almost always some database server there. Certainly anytime you're logging in. So if you're just generally out there browsing the web, even in that case, almost always there's going to be some database that's serving information up. I mean, it could just be a web server, but there's almost always, certainly if you're logging into a system, if you're authenticating, entering a username and password, that's always going to be handled by some database, some sort of database system on the back end, because those things need to store your username, your password, and then think about it. Every time you log in again, let's use email as an example. When you log into an email system, it has to authenticate your username and your password. And then once you log in, then think about all of the things it needs to show you. It needs to serve up your inbox, your sent mail, drafts, all of those things. All of those things are being retrieved and handled by a database server on the back end. So again, just more example of server side of things and client. And again, this client server model you're going to hear over and over. So sort of keep that in mind. Again, on the server side, the database management system, you'll also see that you'll see that called a DBMS. So that's, again, we think about that as back-end processing, and then the client software, again, that's the sort of front end. We think of that as the front end, the user interface. That's most often that's the piece that regular clients or end users are interfacing with. And again, there's mention of an API here, application programming interface, and also application software. Okay. SQL interface, SQL, you'll see that a lot. SQL stands for Structured Query Language. There's some history there. The book does a good job of giving you some history. I'm not going to cover all that here, but essentially SQL is a standard that's 30 or 40 years old now, and it's a standard. So this class we're going to cover MySQL, but SQL is a common standard for relational database software. So whether it's MySQL, Postgres, Microsoft SQL Server, SQLite, I mean, there's a bunch of different SQL applications out there, or database applications out there that use this SQL standard. So it's really the gold standard. Reading through the chapter, then looking at the history of it, we've gone through, there's other sort of document management systems or database systems out there that are not SQL, but SQL has really stood the test of time. We're going on 25 years now. I mean, it's been around sort of in theory for, again, looking back to chapter 30 or 40 years, but as far as it being sort of, the production standard out in the real world, we're going on 20 years now. And it's still really the gold standard for data storage and retrieval. So if you plan on doing great things in IT, whether it's software development or other things, yeah, behooves you to go ahead and learn SQL because it's not going anywhere anytime soon. Okay. All righty. So here's a little sort of another visual that's going to give you an idea of this. Adds the application server to the mix. Again, the client over on the left side here. Client is, you can think about that. That's the interface that the end user is going to interface with, whether it's a phone, a tablet, desktop. That's the client piece. You've got, usually there's an application server that sits in between the client and the database server, so that the application software is running. And if you've taken any programming classes, so think PHP, Java, C++, Python, anything like that, usually applications are built on those languages, and then the application or the application server interface with the database server to sort of send and retrieve data from, and then serve that back up to the client. So again, think of that scenario where the client's on the front end, you've got your phone up here, you're going to enter a username and password, that's sent to an application then sends that to a database server to authenticate a user. Once that authentication's done and you've been approved to log into a server, then there's all this retrieval, this sort of sending and retrieving that happens of maybe specific user data based on your account. So that's just one scenario of how databases might work. But again, this idea of client, application server, and then database server. So when we think about the web, again, this same sort of thing here. And when we talk about web-based, this is not just a web browser, but applications, whether it's cell phones, mobile devices, even Internet of Things type devices, right? If it's a security camera, if you've got it installed at home and it connects to your home wireless network, and then maybe you've got an application that's loaded up on your phone that allows you to interface and view your video camera and retrieve the data. All that is, web-based when we talk about web-based systems. So again, you can see our client all the way on the left here. We're sending HTTP calls, requests, and responses back and forth. HTTP is hypertext transfer protocol. Again, outside the scope of our class, but very important for the groundwork of how all this technology works. We've got our internet cloud there, so you can think about that as, again, that's the sort of cloud-based technologies, and it's your web servers, database servers, all those things are sitting inside this internet cloud. And yeah, so your web server is sending this your web server is sort of the middle person, if you will, for receiving and responding to web-based requests. So yeah, I'll just stop there. I don't want to get too far in the weeds on just how the web works and how web pages work. But anyway, just from a web-based standpoint, you can see that this is a good graphic on what all the moving parts are in a web-based system. Okay, so let's look at some actual SQL tables. So in general, when we talk about relational database systems, this sort of table model is what we're talking about, and that's our framework for how things work. Also sort of looks like a spreadsheet. You may have used spreadsheets either in Google Sheets or an Excel spreadsheet. So very much looks like that. You have rows and you have columns. So the key pieces we want to look at here are, notice you've got a primary key. So these are so obviously the columns are running down here. And so when we talk about the columns, we're talking about vendor ID, vendor name, vendor address 1, vendor address 2, those things. So those are the columns, and that's where data is stored at. So the important things here we'll look at is, amongst the columns, the primary key is important. So when we talk about a primary key, that primary key is going to uniquely identify that row. Okay, now that's important, and again, we'll right now it may not make sense why that's important, but as we go forward, you'll see that's huge, because these systems cannot be ambiguous. And it took me years to sort of really grasp that, but the more data manipulation I've done in software development and programming, everything we do in software development and computers and information technology is, it has to be unambiguous. When I say ambiguous and unambiguous, is a statement needs to mean a certain thing. It can only retrieve one set of data. And again, that's I'm probably not doing a good job of explaining that now, but just know that that primary key is important, because each row that you see here, starting from the top, and notice the vendor ID here is just an increment of 1, 2, 3, 4, and so on. Each one of those rows needs to be uniquely identified, because if, for instance, row number 1 here is U.S. Postal Service, notice the vendor name is U.S. Postal Service. If I'm wanting to retrieve data from a database about a vendor named U.S. Postal Service, I need to make a specific call to a specific row in a specific database table. And in this case, row 1, or vendor ID 1, is going to uniquely identify U.S. Postal Service. Again, we'll be reinforcing that going forward, so don't get too wrapped up in it, but just know that the primary key is going to be key, or very important in being able to uniquely identify and retrieve data in a table like this. Okay. All right, a couple terms we need to know. I won't go through all these, but again, when we talk about the database itself, the entire system, we're talking about, we refer to that as a relational database. Again, table, column, row, and cell. Back on this page, the whole thing here, the entire image we're looking at, would be called a table. Column and row, again, columns are going down. I mean, these are common terms. I'm not just using database systems, but just so we're explicit and we're understanding one another. The columns go down, and then the rows sort of go left to right here. Yeah. A cell, an individual cell, is an individual piece of information here. So again, U.S. Postal Service, that's one cell. I'm looking on row 2 here, P.O. Box 96621. That's a specific cell. In this case, it's the mailing address for the National Information Data Center. But again, that's a specific cell. Primary key, composite key, non-primary keys. Again, the primary key uniquely identifies a row. Composite key is a combination of cells, combination of 2 or more. I guess it can be more than 2. Generally, it's just 2, but a combination of more than one cell to create a unique identifier. Again, the book goes into more description there. And then non-primary keys and indexes too. All right, so we looked at one table, and now if we put more than, so databases are going to be comprised of many tables. An individual table represents a sort of single piece of information, or a single set of data, I guess would be the way to say it. So here in this case, we have 2 tables, and notice this relationship between, in this case, the vendor ID. And so, yeah, so notice that both of these tables have a vendor ID column, and notice the relationship here. So in this case, I'm looking at the table on the top. Notice the vendor ID is 123. That's Federal Express Corporation. And then notice that ID, or that, that ID is referenced down in the table below. And I think this is the invoices table is what we're looking at there. You're looking at the vendors table up top. And so that's what this table on top represents, is vendors. And if you look at the vendor's name, it sort of makes sense, right? If you look at the vendor name column in the table up top, it sort of makes sense. Office Depot, Polestar, Postmaster, Roadway, etc. So those are all vendors, and you just don't have the vendor name, right? This table represents vendors as a whole. So it's the vendor name, vendor address, their city, so on and so forth. And then this invoices table on the bottom. So again, think about taking these different real world things and trying to represent them from a data standpoint. This table on the bottom represents invoices. So what does it take to make up an invoice, or what are all the attributes of an invoice? Well, an invoice has a vendor ID, it has an invoice ID, it has an invoice number, it has an invoice date, it has an invoice total, et cetera, et cetera. I'm just reading these column names across the top here. But notice the vendor ID is the key here, that again, a invoice has a single vendor ID that's associated with it, right? And that makes sense, right? When you're invoiced something, that's a sort of proof of payment or a request for payment from a particular vendor. So there's only going to be one here. So this actually represents what we call a one-to-many relationship, and I think probably, yeah, this next one has terms here. So this is a one-to-many relationship. The idea is that one, in this case, one vendor can have many invoices, right? One vendor, so in this case, Federal Express, they have many invoices. They're doing all kinds of work for this particular business, so they're going to have more than one invoice associated with it. So again, that's that one-to-many relationship. And so when we talk about these relationships, we can have one-to-many, we can have one-to-one, we can have many-to-many. So there's all kinds of data relationships that can be set up out there. And again, the foreign key is going to be key, not to, no pun intended, I guess you'd say, that the foreign key is key here, right? Because the only way to uniquely identify a particular vendor is by that vendor ID. And then when we uniquely identify what vendors associated with an invoice, that's what that vendor ID does for us here. So again, this idea of a primary key is going to be huge going forward. So let's keep that in mind. Okay, columns in an invoice table. So here, if you notice, we had these columns across the top. We talked about those: vendor ID, vendor name, vendor address in the invoices table, things like invoice ID, vendor ID. All of these are data types. So if you had if you had any of the programming if you've had any programming classes in the past, you're probably familiar with data types, and that is that yeah, data can have a particular type. It could be a string, it can be an integer, it can be a decimal, it can be a Boolean, which is true, false. Well, the same is true for relational databases too. And so we see that here. So this is an example of what the configuration of a particular table looks like, right? So again, we see our same thing. This is the invoices. Yeah, this is the invoices table. Notice we've got invoice ID, vendor ID, invoice number. And then notice the data type for each one of these. So int, invoice ID, vendor ID are ints. And that makes sense, right? Because those are unique. They're numbers that I identify and reference back to particular invoices and vendors. And then invoice number. In this case, they've chosen a varchar for that. So variable character, I think is what that stands for. So essentially it's a string. Date, invoice date is going to be the actual data type is going to be date. That makes sense. So on and so on there. Again, so just be thinking about data types as we create database tables. Those types are going to be very important because, again, think about this idea of ambiguous versus unambiguous. We need to be as unambiguous as we can about things. So we want to make sure we have the right data type assigned to a given field. So that way, when we store data in it, we're able to retrieve it and do the things that we want for it. Okay. All right. I'll stop there. Okay. Common SQL data types. So again, yeah, character, variable characters, ints, decimals, floats, dates, all these. And again, if you've had any program, if you've done any programming in the past, you know that variables, specific variables can have data types associated with them, with those. So again, same thing in relational data, databases. All right, terms to know about columns. I mean, this is, yeah. So again, we talked about the data type. Columns can also have null values. They can be null or not. You can allow null values. There's certain cases where it's okay for a null. When we talk about a null value, it's basically a blank value. And sometimes that's okay. Sometimes it's not, right? A good example of that is we talked about primary keys. Every row has to be uniquely identified by primary key. So a primary key cannot be null. I mean, that's sort of like trying that's sort of like division by zero in math, right? It's a no-no. And so in relational database system, that's a very obvious one. So it really just depends on the field and what the data type is, whether it can be null. Sometimes it's okay, sometimes it's not. Generally, it's not. If you can avoid it, I guess that's fair to say. Generally, you do. It's good to have required fields there, or it's good to have always have data in the field. But again, it just depends on the field. Default values, sometimes that's a thing. Rather than allowing a null value there, maybe you put, again, if it's a number, let's say it's an int, the data type is an int, maybe you put the default value is 0 there, right? So it's never going to be null unless there's a value. If there's not a value stored there and there's not a specific value to be stored there, you might always put 0 there. And then auto increment is also a setting you can have for a given column. Often the primary key is set as this, okay? Primary key, it's often not a specific value you're going to set. You just let the database take care of it. So often it's just an incremented number, and just as data, as columns or as rows are added to a given table, the primary key is just set up as an auto increment. So it's just going to automatically stick whatever number is next there, and it generally starts at 1 and just sort of works its way down. Okay, ERD or EER diagram. I usually call these ERDs, which is entity relationship diagram. I can't remember right now. It's not coming to me what the book calls this entity. Yeah, I can't remember. I've always called these ERD diagrams, which is entity relationship the diagram in the past. But anyway, this is just a visual representation of a database. And so we see all of the tables here. So in this case, vendors, general ledger accounts, terms, invoices, invoice line items. And then if we notice, we have lines that are connecting these tables. And a couple things we want to look at. Number one, we're looking at where lines start and where they begin on, where they start on a given table and then where they end on another table. And then also the sort of shape of them. So notice some of these have these sort of little V's. They're actually like a little 3-star shape thing, and then they start off. So those are one-to-many relationships. And then I think all of these are one-to-many, right? So just as one example, we won't cover all of them, and also where they're connecting at. So in this case, let's see. Well, yeah. So in this case, for instance, we'll take terms. Looking at the relationship here. Okay, right. So notice, for instance, and I'm looking at the vendor and the terms table. Notice vendors has default terms underscore ID. And then notice that goes back to the terms table. So the terms underscore ID field is directly related to the default terms ID field inside the vendors table. Okay, so that's what the relationship looks like there. Again, I hope it'll make more sense once we start running queries and actually working with data. And I think we'll look at an example where we look at some real data here. But again, this you'll often see these. This is not just a MySQL thing. You'll see these in all relational databases, and it's just a good way to be able to see this sort of big picture of what a database looks like. This is a very simple version of one. I've seen these that they're blown out. You may have 100. You could have 100 tables there. I mean, think about something like eBay or Google or something like that. I mean, these databases are huge. Amazon, these databases are huge. In fact, you probably can't fit all of the tables that are associated with many of these systems in a single entity relationship diagram. Okay. So how knowing standard SQL helps you. So I sort of talked about this at the beginning a little bit. By far, relational databases are the they're the gold standard for sort of storing and retrieving data in technology. I guess that's the simplest way to say it. So you're almost, it's almost a given, a guarantee that if you go out in the world and whether you're in software development or data munging or any kind of tech in general, I mean, if you're doing any kind of back end systems, you're most likely going to be dealing with a relational database system. So I'll just leave it at that. You'll just have to trust me on that when you get out there in the real world that you're going to be seeing these sorts of systems. And this idea of SQL, knowing SQL, understanding queries, understanding how to create queries or at least read queries is going to be helpful. And then they're talking about standard SQL here. There are different dialects. Again, I won't get too far in the weeds out there, but there's sort of a general there's a general SQL language out there that's it's going to work on most systems. When you start getting into more sophisticated queries, the dialect tends to matter. But there's sort of general SQL, which for the most part is what we're going to be doing in this class. So I say that to say we're going to be working in MySQL here. You'll be learning queries there. Most of these queries, you can take those same queries, and whether it's on Postgres or SQLite or Microsoft SQL Server, those same queries are going to work, or some variants. It's going to be very close to what you've done here will work on other relational database systems too. All right, SQL statements. So we'll be talking about select, insert, update, delete. Very common ones. The majority of what we'll do are going to be these. Selecting data is just that. You're going to run a select query, allows you to retrieve data. Insert allows you to add or insert or add new data to a database table. Update is going to allow you to identify an existing row or an existing set of data, and then update or add to update that given row or rows of data. And then delete is the last one they have there, which is obviously removing data from a database. Statements used to work with database objects. So this is not specific. These commands are not specific to the data part, but actually the sort of structure of the table itself. So creating a database, creating a table, creating an index, and then you've got a couple of alter statements here. So alter is going to be changing that, and then you've got drop statements here, which you can again drop a database, drop a table, drop an index, and so those are equivalent. Drop is equivalent to delete. Alter is equivalent to updating. So you're going to change it, and then create is just you're creating a new either a new database, table, or index. Creating a database, pretty simple. Create, in this case, the command create database AP. AP is the specific name of the database you would want to create here, and then to actually select a database, you would use this use AP or use whatever the database name is. We're going to be working in an Ubuntu Linux environment, so it'll be all command line. So these are things, and again, once I think I'll have a separate video that's going to do commands that you can sort of work through and see examples of those. But again, these are the examples of the commands you'll use to actually create or use a database. So a statement like this creates a new table. Now this looks pretty sophisticated here. There's a lot going on, but the idea here is, notice on starting on the left side and sort of working my way right. Those are the column names. So in this case, this is the invoices table. Notice the first statement all the way at the top, create table in invoices. All of these directives are within parentheses. And so you notice you've got open and close parentheses at the top and bottom. And then each of these columns, notice, for instance, I start on the left and work my way right. Invoice ID And then, so in this case, invoice ID is going to be an int. Remember, we talked about the data type. So it's going to be an int. It's going to be a primary key. So again, we're telling the database we have to, when we create these tables and set them up, we need to set the configuration for the table itself. So in this case, the data type is going to be an int. So it's going to be a number. It's going to be a primary key. So again, each table only has a single column that's a primary key, unless it can also be a dual. It can also be a combined primary key. So it could be two. It could be two columns. Generally, it's just one. In this case, it's just one. And then notice the auto increment is going to be set to. And what that means is, again, in this case, it's just going to start at 1. So the first entry that's made into the invoices table, it's going to have an invoice ID of 1. And then the next one's going to be 2, 3, 4, and so on. And then I won't cover all these, but you can see the other columns and the specific configuration that's associated with them. You can see some of these are ints, some of these are varchar. Notice the varchar 50 here. That means that field invoice number I'm looking at, notice it's a varchar 50. That means it can handle up to 50 characters, and characters are basically strings, so it could be any combination of numbers, letters, and I think you can use special characters if you want to. And then notice some of these null, some of these are set to not null. So that means there has to be a value. For instance, vendor ID is one here. It's set to not null. So if you tried to insert data into this table and vendor ID was blank or null, then you wouldn't be able to do it. You would get a database error, right? It would respond back with an error, and it would not allow you to insert that particular piece of data if the vendor ID is null. And so same for invoice number, invoice date, invoice total. Those are all not null. Notice we've got some defaults here. For instance, payment total. Remember, if you remember, I talked about that. In this case, it's a decimal. And then notice it's the default is set to 0 here. So if you tried to insert data into the invoice table and either the payment total or the credit total is blank, then it's going to default to 0. So if there's no value set for it, it would default to 0. And then there's a couple other things, foreign key constraints and references. I won't get into those, but just this is a good view of what a sample configuration of a database table looks like. Statement that adds new data. So again, these are all the statements we looked at earlier, things like alter table, drop column, create index. I should say something about an index. Index basically, again, I won't get too far in the weeds on this, and I've never been able to, I've never fully grasped like under the covers what an index does, but just know that an index allows for faster searching on a given column or field. So often, for instance, primary keys by default generally have an index associated with them. And so by default, some indexes are created for you when you create a table, and then it's probably outside the scope of this class. We won't do a ton of this, but depending on the amount of data we have and how often a given column might be searched, there might be other columns or fields you would want to create indexes for. I think that's all I'll say about indexes. So this is an example of the invoices table. We've already talked about this some. So what does a select statement? So again, remember, a select statement is going to retrieve data from a database for us. So this is fairly sophisticated here, right? We've got a select statement, and a couple things to notice here. One, notice the structure of what this statement looks like. Notice if I'm sort of looking on the left side and going down, and notice how some of these commands are capitalized. So notice select from, where, and order by are all capitalized. So those are SQL commands. Those are specific commands that are being given. So if you thought of this like a programming language, again, if you have some programming background, those would sort of be like keywords or programming commands that you can give. So in this case, we're going to select from the invoice table. I'm sorry. In this case, we're going to select invoice number, invoice date, invoice total, payment total, credit total. This is going to all be from the invoices table. So notice this from statement. And then we're actually doing some math here. Notice invoice total minus payment total minus credit total as balance due. Okay. And then where, so there's what we call a where clause here, where invoice total minus payment total minus credit total is greater than 0. And then we've got an order by command here we're going to give to, and that's the order is whether you can think of that like ascending or descending. So we're going to order by invoice date. So if you notice the results that are returned here, notice, for instance, I sort of start at the bottom and work back up. We did order by invoice date. So notice this data is sorted, if you will. That's another way to think of an order by statement, is how data is going to be sorted. Notice it starts with July 2022, and so it starts with the latest date and then works up from there. So it goes from July 10th, 2022 down to July 28th. So it starts with the later date, goes up to sooner. So I won't belabor the point by going through this line by line, but this is generally what a select statement looks like. Again, the book goes into more detail, and then you're going to have a chance to experiment with these. So the best way to learn these, rather than listen to me sort of rattle off about it, is to actually run queries, look at the results that are returned, and that's going to be the best way for you to sort of understand these. This is a fairly sophisticated one to start with, but it gives you a sense of what a typical select statement might look like. Okay. Join statements, we're not probably a little too soon to get too far in the weeds on join statements for now, but notice join statements allow you to join one or more tables. So in this case, we're joining the vendors and the invoice table. So notice we've got, again, looking at it on the left side, looking down, you can see the structure of this. This is a well-structured select statement. We've got select from where order by. So we're selecting from, we're going to select, and then you've got, looks like 4 fields we're going to select here. Notice we got this from statement. So we're going to select from the vendors table, and then we're going to also join that to the invoices table, and we're going to join that on the vendor ID field. All right. So notice I've got on this statement, vendors.vendor underscore ID, and then invoices.vendor ID. So if you remember, our primary keys that we talked about and the relationships that we have are based on that primary key. That's why it's essential that these primary keys be unique, because when we run this query, we only want, in this case, we only want invoices from a specific vendor ID. Okay. And we want to make sure that the data between those two tables is married up and it's correct. And I said that wrong. We're returning more than one vendor here, but we only want, we want to make sure that particular vendor and the invoices associated with that vendor, that those two things, again, you can look at them as 2 different tables, that the data being selected from one table is the correct association with the data from another table, in this case vendor and invoices table. And so in this case, the where clause, notice it's where invoice underscore total is greater than 500. So again, any invoice total that's above 500, and notice in this case, if we look at the invoice, look at the results that were returned here, the invoice underscore total, everything there is above 500. So we're only returning, again, those invoices that are greater than $500 in this case. And then notice we're ordering by vendor name and then invoice total. And notice this DESC is descending. So in this case, notice vendor name but then they've also added invoice total in here too. So it's going to be a combination that descending order is going to be a combination of those two. All right, general terms we want to look at in SQL. So query, we've talked about queries. That's what we were looking at earlier. All of these select statements, join statements, all these things, we refer to those as queries. Base table is one. That's again, depending on the context of what we're doing, you'll refer to those as a base table, maybe a results table or results set. So then, for instance, if you run a particular select statement, that data that's returned, it might be stored in a resulting table. That would be called a results table. Calculated value, again, those are just calculations that are being done. And then I won't go into joins, inner joins, and outer joins. I'll let the book sort of go into that, and you can ask me any specific questions you have about those. But again, those are various methods of joining one or more tables and joining the data in those tables to return a specific result. Statement that adds a row to a table. So again, we talked about inserting or adding data. So in this case, we would be inserting data. Again, the structure of these is, so I should say the reason the structure of these is important is not because it's necessary, and you'll see that it's somewhat messy. These statements can be very messy, and the book makes a note about this. SQL is not white space dependent, or it's white space independent. So you can just have a single statement that strings all the way out. It ignores case, so uppercase, lowercase does not matter. However, it makes these statements much easier to read if they're done in a certain way. And again, the examples we've seen up to this point, notice if you look on the left side, the commands, the actual SQL commands are all caps. So that's helpful to be able to read these. And then notice that the carriage returns are done in such a way that for each additional SQL function that's being given or SQL command that's being given, you sort of start a new row each time. So in this case, there's sort of two commands here. There's an insert command, and then there's a values command, and we can see that those are all caps. And then notice insert into invoices, and then these are all of the fields. These are the fields that you're going to be inserting data into. And then notice in the values command is given, and then underneath that, these are the actual values that are going to be inserted into the given columns of the invoices table. Each one of these, so based on the order of what's in the insert statement, the values are going to marry up with those or they. So for instance, 12 is on this first line, so 12 goes into the vendor ID column. Notice this 3289175, that goes in the invoice number column. So these are respective. The order is important here. The order that you see the insert columns and then the values that are below it, those two things marry up with one another. And then the other thing to note is, notice the quotes here, the single quotes. Some of these values have single quotes, some don't. That's going to be based on the data type, right? If it's a number or if it's an int or a decimal, there's no quotes there. If it's a varchar, character, text field, anything like that, notice it is going to have quotes. Dates too, notice the dates have quotes too. Notice the last value is the invoice underscore due date, and then notice that this date string is, notice it's in quotes. So all those things are important. Statement that changes the value. So again, we've got an example of an update statement. I'm not going to go too far into these, but again, notice you've got, again, if you look down the left side, you can see the commands and then the values that are associated with them. So in this case, update, set, where, and then the data and the columns that are associated with each of those commands. We've got some delete statements. These are example of delete statements. So you're going to, just as an example, the one up top, delete from invoices where invoice number equals, and then you're going to give it a specific invoice number. So again, You know, assuming there's only one, I think invoice number's probably a primary key. So if there's only one of those, you're going to be on, you'll be deleting a specific invoice in that case. So here's an example. What I was talking about previously about the structure is important, not from MySQL's perspective, because it can take it can be as messy as you want, and as long as this as long as the spacers are there, and there's not any ambiguities, SQL can process it, but it does make it more difficult to read. So here's an example of that. Notice the statement on the top is a valid SQL statement, and it's the same statement as the one underneath it, but notice the difference in how easy it is to read or not. Again, the one on the bottom, notice all of the SQL commands, the primary SQL commands are in caps. They're sort of left justified, and there's a carriage return after each one. So if you're looking at the bottom statement, I can quickly see that this is a select statement. I can see what table it's from. Notice the from value says from invoices. There's a where clause. I can quickly see that, and then it's going to be ordered by invoice date. Now, if you're looking at the statement up top, much more difficult to read and process and figure out what the end goal is there. We can have block comments. So again, if you've got a programming background or had a programming class, you probably know that you can put comments inside code. SQL is the same way. In this case, you can use this sort of / asterisk for block quotes, and then you can do 2 dashes for a single line quote. And I'll probably give some instructions. I'll probably ask you, depending on the assignments I give you, I'll be asking you to add some comments to your code. Coding recommendations here, again, capitalize all keywords, use lowercase for other code. Separate words and names with underscores. Generally, that's just a good way from a naming convention standpoint, often easier to read. Start each line clause with a new line. I talked about that, how you have a carriage return starting a new line. Break long clauses up into multiple lines, indented continue lines. Use comments only for code that's difficult to understand. So you don't want to over comment code. So again, those are all just good recommendations to follow. Okay, that is all. That is your introduction to relational databases and SQL. So I'll stop there for now, and I'll see you for the next screencast.